The overall goal of this experimental procedure is to present a thermography technique that utilizes a well-designed test section to accurately measure the local instantaneous convective heat transfer coefficients in a single or two-phase pipe flow.
This method can help answer key outstanding questions in transient convective heat transfer in single and multi-phase flows. The main advantage of this technique is that it's non-invasive and can measure fast variations in wall temperature resulting from time-dependent flows. Demonstrating this procedure will be Avram Balas and Yaakov Levy, technicians from my laboratory.
Begin with a segment of pipe 70 centimeters long or more. Its diameter and wall thickness should match the pipe of the experimental facility. Mill 4 adjacent narrow windows along the pipe. Each window is 6 millimeters wide and 80 millimeters long. The gap between windows is 25 millimeters. Next, get 12 micrometer thin stainless steel foil and cut a long thin strip. To help weld the heating wires, the strip is coated with gold near each end of the strip. Continue by measuring the foil's electrical resistance with an ohm meter. Now obtain a rigid tube that fits into the pipe. The tube's outer diameter should equal the inner diameter of the pipe. Cut out a long segment of the rigid tube to create an arch. This long arch, the basis, fits into the pipe and will support and protect the foil. To put the foil in the test